we are going to use those properties now to simplify these types of problems. Now, later on in this class, we're just going to come up with the answer. But for right now, we want to try to use these properties, and we might have to rearrange some stuff in order to come up with the answer, but we will eventually come up with the answer. Notice it says justify each step. When you see directions that say justify or explain, that means more than just give me step by step and then give me your answer. It means you have to tell me what you did. Why did you do it? Okay, justify your step. In this case, tells me write down the property you used to do what you did. So in this case, we have 5 times 3 times n, right? And there's grouping symbols around the 3 times n. Can I multiply those two numbers together right now? No, because I don't know what n is, right? But I can simplify this. What could I multiply together? The 5 and the 3. The issue I have is, right now, the grouping symbols are telling me I must multiply these two together first. But I can't. I can multiply these two together. But really, I can't because of these parentheses that are sitting here. So what could I do? What property could I use to get those parentheses to not be where they're at? Which one moves grouping symbols? The associative property. So if I move the grouping symbols over here, now I can multiply the 5 times 3. So I'm going to write 5 times 3 times n, just like what they have, except now I'm not going to have the grouping symbols there. I'm going to have them there. And that was my first step, and that is the associative property. That kind of looks like somebody else wrote those words. It's actually good handwriting for a minute. So now can I multiply 5 times 3? Yes. And you get 15 times n. That is the second step. And for my second step, my reason is going to be just multiplying. I'm just saying what I did there. I just multiplied 5 times 3. So these are proofs, and they're not that big a deal. All right, I don't have room here. You guys probably do. Let's take a look at the second one. Can we add as is right now? No. What do we need to do? I can't. I have 7b and 8 this is in the grouping, this is not in the grouping. I can't trade those. Order of operations prevents that from happening. I have to do this first, but I can't. It would be nice if the 4 and the 8 were next to each other. Maybe we need 2 steps here. What can we do? I kind of gave you a hint when I said it'd be nice if the 4 and the 8 were next to each other. How? Flip what? So what am I flipping exactly? You're flipping the whole thing? So you're saying that this thing is being added to this? You're not wrong. Yeah. So you're trying to say that we have one thing right here and one thing right here, and they're being added, and therefore I can trade them. I can put this over here and this over here, right? That's what you're saying. If we did that, what property would that be, where I flip around addition? That's the commutative property, yeah. The other way to do this is also with the commutative property, and the result is going to be the same, but this is the one that most people will usually see first. We're going to swap these two. Is that also the commutative property? Okay, I like what you thought of though. So we're going to go with 1, and we're going to write grouping symbol, 7b plus 4, and then the plus 8, and then over here 1. What let us do that? The commutative property. Okay, now step 2, because we still can't add the 4 and the 8, but we can do something now to let us add the 4 and an 8. What can we do? Good, move the grouping symbols. So now we're going to have the 7b, the plus 4, the plus 8, but instead of the parentheses being there, the parentheses are now going to be there. And what property allows me to do that? The associative property. So step 2, associative property. There you go. Step 3, now what? Add them together. We have 7b plus 12. Do I need the parentheses anymore? Nope. So it's 7b plus 12, and step 3, adding. And we're done. That's as far as we can go. But can we add these together? But with that b there, we can't. This is like 7 apples and 12 feet. We can't add those together. They're not the same. So that's the answer. The third one. Some of you can probably see what's going to happen here already. Some of you, maybe you can't. We have 6 times x times y, and it looks like divided by 1 over y, or divided by y, right? But I can rewrite this as 6 times y times, 6 times x times y times what? One over y. This is like 1 over y times 6xy. Kind of like when you have 1 over 4 times 3 halves. You multiply across. Here, if we multiply across, we get 6xy divided by y. Might be the first time you've seen something like that, but that's really what's going on here. So now look right here. The y times 1 over y. What is that? That is a fancy 1. What property allows me to multiply these two things together to get 1? Multiplicative inverse. Nice. So my next step down, this is just rewriting, so we could actually call that rewriting. Step 2, we have 6x. Because the y times 1 over y goes away. It turns into 1, and we don't see it anymore. And we said that was the multiplicative property. Not multiplicative property, multiplicative inverse. Thanks. Can we go any farther than that? 6x? That's it. So that's the answer. 2 steps. So most of the time in math, this is the last page for the section here. Most of the time in math, we use what we call deductive reasoning to show that expressions are equivalent. So we got to figure out what deductive reasoning is. This is one of the vocab words, but it's been a while since we made that word wall, so maybe we don't remember what deductive reasoning is. Maybe I don't remember what deductive reasoning is. Anybody remember? Yeah. Yes. Yes. It's sort of a process. You use logic. It's using logic to basically get an answer. That is deductive reasoning. I'm deducing this from the information that's given. Using logic to get an answer, that is true. Okay? However, to show that a statement is not true, we only need to find one example that makes the statement false. So if I give you a statement, you can use deductive reasoning, use logic to show that it is true. If you want to prove the statement false, then you only need to come up with one specific example, and that will prove the statement false. Doing that is called a counterexample. So this is like a vocab word here. Counterexample is an example that proves a statement false. For example, if you are in this room, you have perfect vision. Is that true? Nope. Why not? Because somebody's wearing glasses, right? Actually, more than one person's wearing glasses. Or maybe you don't see glasses, but they're wearing contacts. Some of us in this room are wearing contacts. So the statement is false. All you have to do is find one reason why. One specific reason. All right, is the statement true or false? If it is false, give a counterexample. So for all real numbers a and b, so we have these two numbers, we don't know what they are. They could be anything. A times b equals a plus b. Is that true or false? False. Is there any time when that's true? What if a is 0 and b is 0? Then 0 times 0 is, and 0 plus 0 is, so that would be true, right? What if a was 2 and b was 2? Then 2 times 2 is, and 2 plus 2 is 4. But is the statement true or false? It's false. Give me a reason why. Pick something. I need a specific example. Give me something for A and something for B. A is 3. B is 3. So we're saying false. And my counterexample is A equals 3, B equals 3. Why? Because A times B would give me 9. So I got to say 3 times 3 equals 9. And 3 plus 3 equals 6. That is a counterexample. I just proved the statement false. I don't have to go any farther than that. This statement is false. All right? Take a look at the second one. For all real numbers a, b, and c, a plus b in parentheses plus c equals b plus parentheses a plus c. True or false? If you think it's false, come up with a reason why. I need a specific example. Do tomorrow. It's true because what? That is right. We just talked about this, right? This is actually the commutative property and associative property kind of mixed together. This is saying I can add in any order I want. That's all that's saying. It doesn't look like that's what it's saying, but that's what it's saying. And that is true. You can add in any order you want. So this statement is true. And because it's true, I won't be able to find a counterexample. Every example I pick, as long as I do the math correctly, will come out to be a true statement. So that's it for this section.